Mosfet biasing circuit analysis. Here is general circuit for the Mosfet biasing circuit. We have here RG1, this one is RG2. Here's RD, here's RS. This is gate, this pin source, and this pin drain. RD, RS, RG1, RG2, and G. This point, the voltage VG, the gate voltage. Now, I can write down the current. Here is ID, and here's RS. IS, RS, IS, RD, ID. And by the property of Mosfet, the current flowing through this gate almost zero. So I here almost zero. The current flowing here is zero. Now, the gate voltage is the gate voltage is VG equal, by the voltage divider formula, we have VG equal to RG2 divided by RG1 plus RG2 times VDD. Here's VDD. So basically, VDD divided by RG1 plus RG2 equal the current flowing through this line. And once we have this current, we time RG2, we get voltage drop between VG and 0 across RG2. Because this is 0 volts, this is ground, so therefore VG equal this expression. Now, the gate source voltage is next one. The gate source voltage VGS is VGS equal VG minus IS times RS. Now, since the current flowing the gate is 0, therefore ID equal to IS. So therefore we have here, since ID equal to IS, therefore VGS equal VG minus ID times RS. So we just plug in IS equal to ID here, so we get this expression, so VGS. Now the drain source voltage is obtained so VDS equal DS VDD minus ID RD minus IS RS. So the voltage between D and S equal voltage VDD minus ID RD minus IS RS. So the voltage drop between D and S is obtained the whole voltage between VDD and 0 minus a voltage drop across its RD and minus the voltage drop across its RS. So therefore VDS equal to VDD minus ID RD minus IS RS. And we can use this expression here, ID equal to IS. So this one's further equal to this. I can write down VDD minus ID RD plus RS. And we define RT means R total equal RD plus RS. Then we obtain VDS equal VDD minus ID RT. So just ID RD plus RS equal defined as R total. So R total, so we replace here. Now we have the definition. Next step, we have to calculate saturation region current and triode region current. First, we calculate ID in saturation region. So ID equal from the characteristic of Mosfet, we have ID equal to Kn VGS minus VT square. So this is for saturation reason. Saturation current. And VT is a number, it's called threshold voltage. Now, once we have this formula, we can substitute VGS, we obtain ID equal to Kn time Vg minus ID Rs minus Vt bracket square. Now I can write down here as Kn square bracket Vg minus Vt minus ID Rs bracket square. Now these ones also equal Kn. So this square minus this one. So this square, okay, first this square Vg minus Vt, this square plus this square ID Rs bracket square minus 2 times this one. So minus 2 times ID Rs time Vg minus Vt. Bracket square. Now I move this ID to the other side. I get so 0 equal Kn Vg minus Vt bracket square plus Kn Rs ID square minus 2 times Kn ID Rs bracket Vg minus Vt minus ID. So this has ID, I put on the other side, so I change the sign. So here's ID, I put here's minus ID. Now in this case, this equation is a quadratic equation about the variable ID. So ID square, and here is ID and ID here. So here this term has no ID. So I have write down here 0 equal Kn Vg minus Vt bracket square plus Kn Rs square ID square minus square bracket 1 plus 2 times Kn Rs Vg minus Vt bracket, not square bracket, then this ID. So if we write down this one, this term is the coefficient of ID square. So I call this A1. And this term include this minus sign. I call this A2. Then this term is A3. So in this case, I have this. Okay, I can write down again like A1 ID square plus A2 ID and plus A3 equal to 0. And this is the quadratic equation for the variables ID. And this one, Matlab has a function for solving this problem. And of course, my purpose is going to use to design a Matlab code for the whole situation, for the whole Mosfet biasing circuit. So this one, Matlab has a function for this problem. Now, next page, I need to find the current in the triode region. Triode region. Triode region, I'm going to use, okay, triode region. I'm going to use next page. Okay. For triode region, ID is given by the following expression. Kn square 2 times Vgs minus Vt Vds minus Vds square. So this is in triode region. Triode region. So ID equal to Kn 2 times Vgs minus Vt Vds minus Vds square. Now, in order to make a life simple, I move this kn on this side, on the left side. So I write down in this way. So ID divided by kn. So I move on this side. So now I have here is on the right side, I have 2 times delta V minus ID RS time VDD minus RT ID and minus VDD minus RT ID bracket square. So where delta V I define as VG minus VT, and this VDD minus RT ID, this term VDD minus RT ID, the whole term equal VDS. So VDD minus RT ID, this term VDS. And of course, RT I define as the same thing. RD plus RS. Now I need by distribution law, so I need to multiply everything together. I want to find, eventually I want to find what is ID is. ID. And on the left side I have ID, and here I have so many terms with ID, so I just simplify. So I write down here ID divided by Kn equal 2 times delta V times VDD minus 2 times delta V RT ID minus 2 times ID RS VDD plus 2 times ID RS RT ID. Then minus VDD square plus RT square ID square minus 2 times VDD RT ID. Now I going down further, 2 times delta V VDD minus 2 times delta V RT ID minus 2 times ID RS VDD plus 2 times RS RT ID square. Now here's minus VDD square minus RT square ID square plus 2 times VDD RT ID. So I want combine the like term. For example, the first term has no ID. I write down as this symbol. So this one also I write down this symbol star. Okay, this term I write down this symbol, and this term, this symbol, and this term I write down as triangle term, and this one, because this is a ID square and this also has ID square, I write down as triangle. And this one, so linear term of ID here, so I write down here as like this, the same symbol as this. Now, I can write down, I can combine the like term together. I have here's ID divided by Kn equal two times RS RT minus RT square bracket ID square plus bracket 2 times delta V. Okay, I write down here delta V time VDD. And minus VDD square plus, okay, I have used next line, 2 times VDD times RT minus 2 times delta V RT minus 2 times RS VDD ID. So what I did is here is this term I combine out here. So this one, so this term, and this term is star term, star term, and this term is this term. So I just combine star as here, and this term, this one I combine here, and this term I do on here. So now I have all this term, and next task is I need move this term, this linear term in ID on the right side. So I got 0 equal 2 times RS RT minus RT square. So ID square plus 2 times VDD RT minus 2 times delta V times RT minus 2 times RS VDD minus 1 over Kn. So this term I move on the right, and then I take ID out, so I get ID here. And then I write down as here. Okay, this term, the coefficient of ID square, I call it B1. And this term, the coefficient of ID, linear term, this one I call B2. And this term has nothing to do with ID. I write down on here. Plus 2 times delta V VDD minus VDD square. Now this term I called B3. B3. Now I have again a quadratic equation for ID. Now I can write down in this way: 0 equal I can write down 0 equal B1 ID square plus B2 linear term ID plus B3. And this is B1 ID square plus B2 ID plus B3. And this one, this function, I can send to Matlab to solve. Matlab to solve. Now, I have okay. I have to write down here. This is for triode region. Triode region. So triode region. Now, I have to solve. The problem of the problem for the VG value for determining one the Mosfet in triode region and one the Mosfet in saturation region and one is Mosfet in cutoff region. So I draw this curve. First, I draw a horizontal axis. This is VGS. Now, and this point equal to VT, threshold VT, and this point VT plus VDS. If VGS smaller than VT, in this region, okay, I write down here a vertical line. Vertical line. Okay, this is cutoff region. Cut off. So in this area, ID equal to 0. And here's VT. From here to here, it is saturation region. Saturation region. And from here on, triode region. Triode region. Now, and this point, VT, I could call point A. Okay, this point A. This point I call point B. Now, in this region, VGS smaller than VT. So in this region, VGS smaller than VT. Now, in this region from A to B, VGS from here to here. So VGS smaller than VT plus VDS and bigger or equal VT. And in this region, in this region, Vt plus Vds smaller than Vgs. So Vgs bigger than Vt plus Vds. So this is the Vgs region distribution from here to Vt and from Vt to Vt plus Vds. And this cutoff, this saturation, and this triode. Now, to program in Matlab, this variable Vgs is not convenient. What we do here is, we want to change variable. Okay, change this variable Vgs to Vg to programming in Matlab. Change this variable to Vg. It's easy to program in Matlab. So what we do here is I will draw another picture as this. I draw Vg. So Vg is the variable. Now we want to see what Vg value what look like. So Vg, now in this region, okay, by definition this. Vgs is equal Vg minus ID Rs. Now, in this place, Vgs equal to Vt. This place, Vgs equal to Vt here. If Vgs equal to Vt, then we have Vgs equal to Vt, then we have Vt equal Vg minus ID times Rs. Now, if in this region, cutoff region, so ID equal to 0. So in this region, ID equal to 0, then I have ID equal to 0, so I have Vg equal Vt. So in this place, I can write down here Vt here. Now, I can write down here Vg smaller than Vt. Vg smaller than Vt, and this cutoff region. Now, once Vg greater equal than Vt, in general ID, the current ID is not equal to 0. So Now I can write down here this point as Vt plus id times rs. I will go wise like this. Okay. From this equation is the definition of the region of VGS in saturation region. So I need to solve this equation to find what the equation is for VG. And I will find out what this value will be. So I just go over this equation. And this equation is this. This equation is this. I write down this equation. This equation, okay, I had to write down. Okay. This equation is Vt smaller than equal Vg minus id rs. So VGS equal Vg minus id times rs, and also smaller than Vt plus Vds. So smaller than Vt plus Vds. Now, okay, I just replace VGS as Vg minus id times rs. Now, therefore, from this equation, therefore, I have this is the sign of therefore. Therefore, Vt plus id rs smaller than equal Vg smaller than equal Vt plus Vds plus id rs. What I have done is, from this equation, I add the term id rs on each place. So id rs on this term I get plus, and this one disappeared, and this one plus id rs. Now, and this one I can write down further as Vt plus id rs smaller or equal Vg smaller than equal Vt plus Vdd minus id rt plus id rs. Because Vdd minus it rt, this term equal to Vds. Now, so I can write down further. So Vt plus id RS smaller or equal VG smaller equal VT plus VDD, and IT equal to the definition of IT, no, so RT equal, okay, I have to write down here, RT equal definition equal RD plus RS. So therefore, I can write down here as VT plus VDD minus ID RD minus ID RS plus ID RS, and this term cancel with this term, so finally I get VT plus ID RS VG smaller equal VT plus VDD minus ID RD. This equation is the equation VG has to satisfy. So therefore, once I have this equation, I can put this quantity and this quantity on here. Okay, so this one's VT ID RS, and this one is equal this quantity equal VT plus VDD minus ID RD. So what I'm trying to do is, I know on the saturation region, so VGS satisfy this between these boundaries. So VT and VT plus VDS. Now I want to change this VGS to VG. So I want to find what is VG, the range for VG, if the Mosfet is on the saturation region. So I just change VGS to VG. So I from this equation, which is equal to this equation, and this quantity VG minus ID RS is VGS. So I just change VG. I want to find the range for VG. So now I found it. So the range for VG on the left side is this one, on the right side is this one. So I copied this quantity on here, and this quantity on here. So now I found for saturation region what VG value will be in this region, okay, in this area. Now for triode region, this is triode region. For triode region, I have triode regions here. triode region here. So I need translate this equation to the equation Vg satisfied. So I use next page this. So I want to translate this equation for the Vg. This equation for VGS. I want to find Vg. What equation will be satisfied for Vg now? Okay, I do like this. I have here this equation. I write down here. Okay, this for triode region. For triode region, I have Vt plus Vds smaller than Vgs. So therefore, Vt plus Vdd minus Id Rt smaller than Vgs equal Vg minus Id Rs. So therefore, I move this term on the left side. I have Vt plus Vdd minus Id Rt plus Id Rs smaller than Vg, and therefore Vt plus Vdd minus Id Rd minus Id Rs plus Id Rs smaller than Vg. Therefore, so IDRs, they cancel out. IDRs cancel out. So I have here's Vt plus Vdd minus Id Rd smaller than Vg. Now, this is Vg if the Mosfet operates in triode region. Vg must be greater than this value. So this one I put this value on here. So Vt plus Vdd minus Id Rd. Now I have triode region, I have saturation region, I have cutoff region, I have everything defined for Vg value. Now since I have the Vg value, I can make a Matlab program. The program must satisfy these conditions. And for each current, I can solve in the previous page. I can solve for saturation region. For saturation region, I have this equation in the previous page. Saturation region For triode region, I had it before. Triode region in the previous page. I have here triode region in the previous page. So then I can make a Matlab program. Here I'm going to show you Matlab code. I have 3 files here. The main file is Mosfet general circuit analysis.m. The other one, Mosfet.m, is for plot the graph of Mosfet characteristic curve. The third one, .png file, is for plotting the schematic of Mosfet biasing circuit. Let's first look at the main one. This is the Mosfet general circuit analysis file. This page shows line number 1 to line number 39. And next page, I'm going to show you line from line 40 to line 78. On next page, I'm going to show you from line 79 to line 117. On next page, I'm going to show you from line 18 to the end. You can see at the end of this program, the function Mosfet is called. So this one is the Mosfet. It just like plot the graph to show the operating point is located where in the graph. You can comment this line, or you can leave it open to run this file. But this one is optional. You can comment out this line. Let's try run this program. Click the button run. So you see the schematic is shown, and this schematic is from this file, Mosfet circuit general.png file. Here we have RG1, RG2, we have RD1 and RS1. Just forget about this one after RD. Forget this one from RS. And now I can use, so VDD, I gave examples 8 volts. VT is threshold voltage, I gave 1, for example. KN, I gave 0.00025. And RG1, I gave 150 kilo ohm. I put 30 after, so in units ohm. And RG2 also I put 150, 3 zeros, return. And RD I put 2200 ohm. Is 2.2 K. And RS equal 1000 ohm is 1 K. Now, the answer is the Mosfet is operating in the saturation region. VGS equals 3 volts. Drain current ID equal to 1 milliamp. And drain source voltage VDS equal 4.8 volts. And the graph is shown also. You see, VDS 4.8 is here, and ID equal 1 milliamp. So you see, you have the characteristic of Mosfet, and also the red dot tell you where the biasing point is in the graph. And I'm going to show you the graph file called Mosfet file. I open this one. Mosfet file just has one page. This is the Mosfet graphing file for the characteristic curve of Mosfet. Just one page. So line 1 to line 37.